Alright, so right now we're gonna do 2005 AB Calculus question 5. Alright? Question A says, find the integral from 0 to 24 of v of t dt and also explain the meaning. Alright, so if you look at A right here, you do you're gonna do the integral from 0 to 24, right, of v of t. Right, that means the integral itself means that's the area. So what we have right here is 1/2 times 4 times 20. The meaning of the integral of v of t dt from 0 to 24, it means that the distance that the car traveled in the first 24 seconds was 360 meters. Alright, so in part B it asks us to find v prime of 4 and v prime of 20 and explain if it exists or not. So we're going to start off with v prime of 4. So since v prime of 4 it doesn't have a straight line and the slope is not the same throughout the instance that it is in. And since it's a corner, we're not going to have a derivative at time t equals 4 when considering v prime. Now, however, we can do v prime of 20, right? We're going to use the equation v of b minus v of a over b minus a, where v of b will be 20, v of a will be 0, b itself will be 16, and a itself would be 24. Okay. After that, you're going to subtract and divide. So you get 20 over negative 8. You simplify that, and that gives you negative 5 over 2 meters per second. Alright, so first let's start off with v prime of 4. So there's not going to be a derivative at v prime of at time 4 for v prime because it's a corner. You can't have a derivative at a corner. There's no slope. Now for v prime of 20, you can do the equation v of b minus v of a over b minus a, right? Where v of b would be 20, v of a would be 0, and as we see in the graph, b itself would be 16, and a itself would be 0. Right? And then you do that, you get 20 over negative 8. Simplify that, you get negative 5 over 2 meters per second squared. All right? And we already explained why v prime of 20 exists and why v prime of 4 doesn't exist. So now, all right, so in part C, it asks us to write the piecewise function for a of t, right? So in order to do this, we need to find the acceleration at each section of the graph. So from 0 to 4, the slope would be 5 meters per second squared. From 4 to 16, the slope would be 0 since it's horizontal. And from 16 to 24, it will be negative 5 over 2. Right? So now that you have all this, since you have all the accelerations, now you just put it all together. We know that v prime means the acceleration because that's the derivative, because v prime is the same thing as the derivative of v, or velocity. Right? So we're going to do, in order to find the acceleration at each time, we're going to do, so a of t equals, from 0, when x is greater than or equal to 0 and less than or equal to 4, the acceleration is 5. When x is greater than 4 but less than or equal to 16, the acceleration is 0. And when x is greater than 16 but less than or equal to 24, the slope is negative 5 over 2. Part D asks us to find the average rate of change from 8 to 20, and it also asks us, does the MVT prove C? Right? So for the first part, in order to find the average rate of change, we're going to do f of b minus f of a over b minus a, where f of b is 10, f of a is b is itself is 20, and 8 itself is a. So you're going to simplify that, and you get negative 10 over 12. You're going to simplify that again, and you get negative 5 over 6 meters per second squared. Now, it proves that C doesn't exist.